Hello world, it's great to be back. It's been 2 weeks since the last stream and this is now edition 2. Thank you very much everybody joining in and let's code. I just before the stream started, 2 new followers. That's Timo and Boschkitzer. Thank you much for joining in. So what's on our agenda for this session? Let me zoom in. Oops, actually, start the tooling. Yes. So today is gonna be about, oops, I actually made a copy paste error here. Today is about diagnostic suppressors, everything how we can suppress diagnostics, compiler warnings in .NET, and how we can programmatically do it via Roslyn. So this will be another Roslyn heavy session. But before we go to that, we will first have a couple of follow-ups from the last time. I promised to go into detail what mutation testing is, and last time I had some troubles with implementing the diagnostic analyzer and code fix that we've built. I got some more news on that, and also a note on nullable reference types. Then I guess we will do a brief break and then dive into suppress diagnostics in .NET. We will have a look at the new-ish net analyzers which have been added since the .NET 5 SDK. They are now included. We will see various ways of how to suppress diagnostics. And then we will check out a specific diagnostic, if we have time, also a second one, and how we do that how we can suppress it via Roslyn. So we have some logic on when to suppress it. And at the end, we'll always have a look at code coverage report and mutation testing report. So let me get started with what is mutation testing? I do have a slide on that. It's actually from a previous talk of mine. Presentation. It's here. So mutation testing is a technique of how to test our code, and it complements unit testing. For mutation testing, we need a specific tool, and that tool then does small modifications to our production code. For example, it changes a plus to a minus, or an equals operator to a not equals operator. And for each of those small modifications that the mutation testing tool creates, all of the tests, or at least the impacted tests, which are those tests which actually cover this changed production code, then with those set of tests, at least one test must fail, because that means we changed our production code and then one test failed. So this line of code wasn't not just only covered, but also asserted against. So one expectation now failed. And this is when we have killed the mutant. If there is no failing test, although a piece of code was changed in the production code, then this mutant survived. And this now gives to a code coverage report an additional metric of how effective our test suite really is. So let's have a look at the latest mutation test report from the repository that we had a look on last time, the analyzers repository. We can go to the result on Azure DevOps. And we can have a look at the test tab. So we have 133 total tests. All of them are passing. That's cool. We have a code coverage report, which a combination of Cobertura and the report coverage tool. And then we can also have a look at the mutation report. And in the mutation report, let's actually have a look at the diagnostic that we built last time. This is the implicit record class diagnostic. We can now see that 16 mutants have been created and killed. 10 mutants have been created but survived. So I had no assertion against this change. And also with the configuration I have, 5 of them are ignored. So so this tool that I'm using here is called Striker.net. This is available as a .NET tool, so you can install it either globally or locally to the repository. And then we can run it, and it creates the mutants, runs all impacted tests against, and then creates this report. And for example, Striker here, we see this string with some characters has been changed to a 0-length string, but no test failed. So I actually don't have this covered. Now, I didn't find out how to actually cover these strings and also this Boolean here, which is enabled per default. So the testing framework I'm using, I need to get a little bit more familiar if there is a way that actually can test it. But the actual core of the logic, we see our debug assert statements, they're also not asserted against. Actually, I should ignore them. I will do this afterwards. But all of the actual logic, no mutant is surviving there. So that's cool. We can have a look at what mutants have actually been killed. So Striker actually here remove this return statement. So the flow now has changed, but at least one test failed. So we got here, this is the test which checks that we indeed have C#10, that our compilation we are in indeed is C#10, and so on and so forth. So this is what we developed last time, and mutation testing now gives a nice addition to the code coverage report and tells us all of the logic, all of the meat of this analyzer and also the code fix are asserted against. So the test coverage, the effectiveness of our test suite is pretty good. I actually have a lightning talk on mutation testing. If you want to have more, I will link it up in this discussion afterwards if you want to go into more details. Now to the follow-ups from last time. So let's open, I'm now jumping to Visual Studio, and open the analyzer, the diagnostic analyzer that we've built. It's diagnostics. Last time I wasn't sure about which name to use. I now slept over it a couple of days and settled now to create a new category, called it the clean code category, where I want to put rules in which don't really affect the runtime or the logic of the code, but only the improve readability of the source code. And also added nice descriptions. And also added a link, so we can see this if I would go ahead. I have a test project here. Now, here we defined a couple of records, a regular C#9 style record, a C#10 style class record. Both of them, they are semantically equal. Both of them are a reference type record. And with C#10, we have two new records. We have the record struct and the read-only record struct. And I would like to have here a warning to be, if we are in C#10, have an explicit class here to indicate to the reader this is really a reference type and not a struct type, a value type. So we can add this package, publish this to NuGet. So we see this is brand new, has been released yesterday. And once I install this package, now I wait a bit, and now the warning appears. We see here now comes the squiggles. And indeed, this is now our new diagnostic that we built. And we have a clickable link here that we can follow to go to more documentation of this analyzer. And we've also deployed the code fixer, so I can hit either Alt-Enter or Control-Dot and say, this is now the associated code fix, which adds the class keyword. So we wrote a lot of code and a lot of test code to basically add the class keyword and the space character, so 6 characters, but it was totally worth it. Okay. Also last time I had an issue that this diagnostic that we have created got actually reported twice. If I jump again to the unit test, so here is a unit test. I then modified these a little bit to cover like really all of the combinations that a record allows. So like basically an empty record, an empty with an empty parameter list with some positional members and so on and so forth, and derived and with an attribute on it. And all of them, they always got reported twice. So what we needed to do last time is basically always expect every diagnostic to be there twice. And the thing is, this is actually working as intended, because let's jump to the source code of the analyzer. We have registered ourselves to every record declaration. And when the analyzer detects a record declaration, then this callback is fired. In here refers to the check, are we indeed C#10, otherwise ignore. And then we extract the record declaration syntax. And here we received the record struct declaration twice. We went into this callback twice. And what I then did is we see that if check here. So if the containing symbol is an INamed type symbol, which is basically the record class declaration or the record declaration, then we report the diagnostic. Unless if it's not an INamed type symbol, then the containing symbol is a method symbol. So this is for the primary constructor, which is created via the positional syntax. So this is actually by design. The record struct declaration gets fired twice, and we need to filter that it is on the type itself, but not on this generated method. And now with this check in place, then actually the diagnostic got reported only once and not twice. I also linked it up in the discussion here. So there's a GitHub issue about it, and this is actually, so this is working as intended, I believe, for backwards compatibility. And another thing I wasn't so sure about is because with the diagnostic, let's jump to the example again, we also report the name. So this is actually the name of the record. If I would change that, I call it now record 123. Now we see in the string, this is actually also the record 123. So I want to use the name of this record type and put it into the message. And there I wasn't sure whether we should use the value text of this identifier. Maybe as a brief refresher, let's briefly jump to SharpLab. Sharplab.io. And let's declare a public record, my record. And then we see in the syntax tree here how this record looks like. So we have the record declaration. Now this record declaration consists of the public keyword, the record keyword, and an identifier, the my record identifier. And this identifier offers either a text or a value text. And there is a difference that I wasn't aware of last time. So the difference is that value text actually refers to, I will show it in the test. It will be clearly visible in the test. Because in C# we can't use non-contextual keywords as identifiers, such as int. We can't use int or bool as an identifier. But if we add an @ symbol before, like I did here, then we can actually use that as a name, and then it's a valid identifier. But for the diagnostic, I don't want the @ to be included. I really want the raw identifier name, but not some escape character like this @ here. And in that case, we need to use the value text. If we would be using just the text and run this test, then we would see this test fails because now the message that we put out then would also include the @ character. So here is indeed the test is failing. That's this one. And oops. Test Explorer, let's make this a little bit bigger. And we see here that we expected the message record class identifier is declared implicitly, but the message actually was message class @ identifier is declared implicitly. So if we use text includes some escape characters, but value text, this is the value text, does not, which is the raw identifier name. And so this is why I then decided to use the value text. So, and then one last follow-up from last time I noticed is a little bit on a follow-up of nullable reference types, because with nullable reference types enabled, that actually helped me find a bug in the code. It was in a different analyzer. It was in the analyzer that I also showed last time, which suggests to use pattern matching for null checks. And in there, we had, let me briefly recall, when we check for the method. Yes, we get the method and check if it is here actually, yes. So the bug was that if a user would have declared an, let's go to an example and show this. Oops, sorry, wrong example. Where are my null check examples? Do I have them in? Where do I have them? No. So I have it as a fixer. There it is. Yes, sorry. For example, I have here a record type, and if the user would on this record type now declare a public static equals method, which takes, which is bool returning and takes an object or any parameter. Come on. This would now also crash the analyzer. So actually, let's return false here. This is not allowed because it already defines such a member, but still with that in place, this would crash the analyzer because what I had in place, I didn't check if this operation instance was null. So actually this piece of code was missing. And then when I updated, because last time we also updated from Roslyn 3.8 to 4.0, there have been new nullability annotations obviously being a bit improved. And then I got this this warning here. So this instance may be null. And then I found out that this instance, if it is static, is indeed null. And so I didn't have this static check in place. And then actually later on, because this was null, then crashed the analyzer. And then you get in Visual Studio that analyzer ID has failed or something. And yeah, this is not a really nice experience when it produces warnings that the user can't do anything about it. So this actually then fixed it. So the lesson for me is, yes, always return nullable annotations because they may reveal errors. Cool. And this was all the follow-ups that I wanted to share. Now, okay, before we have a brief break, let's do a bit of a context. Let's get the context about where I want to go with diagnostic suppressors. So there have always been a lot of NuGet packages which offer analyzers. And with .NET 5, a lot of them have been now included in the SDK. So previously, they have been in the Microsoft Code Analysis Net Analyzers package. But with the .NET 5 SDK and higher, they are now actually included. So per default, they are enabled, but only a handful of rules in the code quality analysis category. Not category, but analyzer group. So per default, a handful of them are, or two handfuls of them are enabled, but we can enable actually all of them. So let's do that with the analyzer project that we have. I could now go and add this to each and every CS proj that we have, but we have a lot. So I always like to go to the root of this repository where I have a directory.build.props files. And this file gets applied automatically. That's a well-known name to MS Build. Gets automatically applied to every CS project, which is in the hierarchy, on the same hierarchy level or below that file. But only the first one is found. If you want to have a recursive finding and merging of these directory build props files, you can add an import statement, which basically says get path of file above. So this means it gets the next directory build.props, be it in the direct parent directory or farther. So then it searches until the root of the file system finds any other directory build.props. So if we don't have this, then it would stop here. And I always like to do this in the root of the repository, to have one which actually then stops here, so that no other files that the user potentially has on the file system then would change the rules and then maybe cause compilation warnings or even errors. And so we can now enable here the Net5 code quality analyzers for the entire solution. Let's look up how this is working. So there is this new enable net analyzers property. Let's go to documentation and we do a new property group and enable them. So per default, actually they are enabled if we are targeting Net5 and higher. But I still want to enable it explicitly because analyzers always need to target Net Standard 2.0 as well. And so for the Net Standard 2.0 target, they wouldn't be enabled per default. So for these, and also the tests that I have, because I test for both Net 6 and Net 4.7.2, that's .NET Framework 4.7.2, because the analyzers still need to support Visual Studio. Visual Studio is built on .NET Framework, so this is for compatibility. And so this is why I want to explicitly enable it. But now just a handful of rules are enabled and not all of them. I prefer a stricter rule set and then opt out of those that don't apply to my solution. The other direction would be to have all of them disabled per default and then enable them which apply to your solution. But I personally prefer the more aggressive way of enabling analyzers. So we can, this is now called the analysis mode. This has been changed in .NET 6. In .NET 5, there have been a little bit, I think only 3 analysis modes. But now with .NET 6, you can control them even more. So you can either say none at all, the default, which we have right now, what we saw above, this 2 handful of rules. There is a minimum rule set, a recommended rule set, or we go with all. And let's start with going with all. So let's copy this, put it into our directory build.props. Actually, move it up here, get rid of this. And now, if we build, I would expect a lot of warnings that previously haven't been reported. So we actually have, did I not? Oh, this should be gone. Yes, I reverted it. Cool. We have 317 warnings now. Let's see. This now brings me to the topic of how to suppress warnings. So we either fix them or we suppress them because they may not apply to our context here. So this actually should go away because I reverted this. But let's have a look at some of them. I will pick out those which make sense. For example, here, that's a nice one. So the behavior of string starts with could vary based on the current user's locale settings, which is interesting. So depending on the settings, this could then behave differently. I would say it's unlikely, but maybe there is some locales that perhaps include a different a different S-like character, maybe with with a chevron. Is that called? I'm not sure. So there's different variants which could be included as well, but I actually would like to be very strict. So this analyzer now suggests to explicitly state the intent and not implicitly receive it from the current user's locale. And I would say let's do an ordinal check. So this is this would do a check on an underlying type level. So it would check the character by character. And let's add them to all of them, which now could fix a potential issue. Let's pick another one. I have some unused. I want to show now one that would make sense to ignore, actually. Come to that later. Actually, let's come to that because this is what I want to show later on. So there is an analyzer which reports. Does it show up? Yes. There's an analyzer which reports CA1707. And this analyzer, if we follow the documentation, wants us to remove identifiers, remove underscores from identifiers. And there is also, now this is conflicting with a different best practice. Let's check out the documentation of the testing best practices. Unit testing best practices, I linked them here. So here actually it is suggested to naming, when we go to naming our unit tests, it is not expected, but suggested to have 3 components in the names. First, the method under test, then the scenario under which this test runs, and the expected behavior or expected outcome, so the thing that we then assert against. And usually those components are then separated by underscore characters. So what I would like now to do is to ignore this warning for test projects, because this is the style I want to use, and so this warning shouldn't apply there. It should apply for all of the production code, but not for the test code. So if we want to narrow it down very explicitly or specifically, it should only apply for methods which are tests. So they have the fact attribute from XUnit, or they have the test method attribute from MSTest, or the test attribute from NUnit. So let's see how far we can go by ignoring it as specifically as possible. There is various means of suppressing the warning, and I will show some of them. One way is, Visual Studio suggests one of them already. If I hit Control dot, we get the suppress or configure issues selection here, and we could suppress this CA1707, or we could configure the severity. Currently the severity is set to warning. This is a warning. We could change the severity to, for example, an info, or we could also make the severity more strict. We could also set it to an error, so that the compilation would fail even without warnings as errors. And one of those variants to suppress it is to do it via a preprocessor directive, which looks like this. So we have a pragma warning disable, and then the ID of the warning. And then it's disabled from this statement until the end of the file, or until we have a warning restore. So this is very, very similar, like we can disable, enable, and restore the nullable annotations. But I personally don't like this kind of suppression because it really, for me, hurts the flow of reading. So we could put it on the top of the file and then remove the end, or put the end at the very end of the file. So this would be one way of ignoring, of suppressing this warning. But here we now have, so we would need to apply that to each and every file. This could be tedious. And also we would suppress this warning also for things that we perhaps, that are not test methods. If I have like a private static helper method, my helper method. Now the underscore rule perhaps here should still apply, but it would now still be, it would be suppressed because we can't, we just either disable the warning or we don't. We can't conditionally disable the warning with this variant. So let's have a look at another variant. Another variant would be to put a attribute on top of the member. This is also offered via Visual Studio Quick Fixes. We can say, if we say suppress via an attribute, and this would now create the suppress message attribute, which looks like this. Let me remove the namespace. So this is in the System Diagnostics Code Analysis namespace. And we pass in the category, the identifier with the description, and we can add a justification, which is cool. So I could say this is a test method. So now have also in source a reason about why I would suppress this rule. So we could now add this on a member level. We could also add it on a type level, so ignore it for the entire class. Or we could put it on an assembly level. We can put assembly before. Assembly. And then there is various means of, must proceed. Okay, so I should put this in a, not in the namespace, but before the namespace declaration. And if it applies to the entire assembly, so to the entire project, maybe it's not the best idea to put it into a random file. Maybe there should be some global suppressions file. I think this is the convention where we put assembly level suppressions in. This can also be more configured. If we jump to the documentation via the suppress message attribute, on an assembly level, we could also specify a scope or a target. So perhaps so that it only applies to maybe only one member or an entire namespace. But still, with this variant, we can't really distinguish test methods from other members. So that's still not, I would still here have this method not flagged, but I still want to have this. I only want to have real test methods that can actually be run by the testing SDK. So there is one more method that I want to show. We can also suppress warnings via MS-build, via the no-warn attribute. So let me remove this. Now the warnings appear again. And we could go to this assembly, to the CS proj, and add a no-warn here, where we now say, okay, I want to ignore CA1707. And now the warning goes away. So this is now for the entire project. What you want to do is always include previously mentioned no warns, because perhaps there is a directory build.props which already defines a set of no warnings. This could also be chained. We could have multiple semicolon separated. And maybe this is already declared in the directory build.props. Then this would overwrite the previously defined CAs. Maybe we want to ignore a different warning on the entire solution level, but those just on a specific project level. So in order to include already defined no warns from directory.build.props, or previously imported properties files, we can just state the variable here, and then we add to what was there before. If it's empty, we now just have 2, but if there have been like 7 no warns before, now we add 2 on top. So always add don't overwrite the previously defined no warns from a higher hierarchy. And this still would only work on entire project level. So this use case that I would like to have, that non-test methods are still ignored. Now there is 2 more well-known files that the .NET SDK is aware of. It's the editor config and the analyzer config. And via these 2, we can now control the severity. So the previous 3 examples, we had a preprocessor directive, the suppress message attribute, and the no warn. We can say we can suppress a warning entirely. We cannot change the severity. Via editor config, we can do that. So there is also a quick fix for that in Visual Studio. I removed the no warn, now the warning appears again. It's still the CA1707. We can hit Control dot and now go to configure severity. And then we get a, let's say I want to set it as an error. Let's go the other direction. So if I preview changes and scroll to the end, this is the configuration that we could add. So let me actually grab this. And now there is 2 places we could put this. We can put this either to an editor config, which I have in this project in the very root. If I open this, Visual Studio 2022 has a editor for the editor config files, but I want to get the raw representation, so I open it in Visual Studio Code. There it is. And I would now search a C# section. There we have, it should only apply to C# files, and then could add the string that I copied in here, where we can say this is like there is a specific format in the documentation. You could read up more about that. The .NET Diagnostic with the ID CA707, we set the severity to error. And now we override the default severity of a warning to enforce an error. And if we would go to Visual Studio and go to that file, now this yellow squiggle should turn to a red squiggle. And this is now an error. But we could also go into the other direction. We could change it, for example, to an info. And as an info, we won't get it anymore in the error list of Visual Studio. So .NET Build won't show up. But we still have a, if we see it, no, we don't. So we don't see it, but it's still there. So okay, actually I thought I set it to info. Maybe I'm using the wrong string. Let's have a look at the documentation of how to configure these. Editor config, and we can set the severity warning. was hoping it's... There it is. There they are. Oh, okay. It's not info. It's actually silent. My bad. So those are the severity levels that we can set. We can set to error, warning, a suggestion. This is what I meant. So in Visual Studio, it's in the info tab, but in the editor config severity, it's called a suggestion, or we can do it to none. So if I set it to the suggestion, this is what I wanted to do, and save it, then in Visual Studio, in the error list, it would still show up. There we actually see it. It now shows up as a message, so as an info message. So it's no longer a warning. So if we do a .NET build, it won't show up. And we see in Visual Studio now those 3 dots. They indicate diagnostics of the info or of the suggestion severity. So it's still there. If I hit Control dot, we still get the fixer, the associated fixer, which is removing those underscores. But there is no more a warning. So this is one way how we can control the severity. Another way is to, because I personally don't like to put it into the editor config. So the editor config mostly contains styling rules, such as we prefer in this solution expression-bodied members when they are on a single line. But suppressing diagnostics, I find a little bit weird to do it in an editor config. So I think this was added with .NET 5. We can now also have a well-known file called global analyzer. Or no, it's the file is called global config. So the name, if we want .NET to pick that file up automatically, it must have the name .globalconfig. If it has a different name, we would need to explicitly specify the file in an MS build property. But the .globalconfig is very similar to the .editor config. It is picked up automatically, and we need to set the isGlobal to true. And now, again, this is the same hierarchical structure as with editor config. The closer this file is, the higher the precedence of the rule we define. And we could now add it here. We don't have this C# section that we saw in the editor config. Since the editor config has this C# section, or has in general this pattern section, depending on which file it applies, the global config does not have that. And we could change the severity of this rule in this file too. We see in this project already did change the severity to none of some of the files, since we are here in this example project where we want to have the code a specific way in order to have the diagnostics that we produce showcased. So those are now 5 ways of how we could suppress this CA1707, but none of those ways is really precise enough where we can declare that this should only be ignored for unit test methods, which are actually vulnerable if we do .NET test, only on those methods, but no other method. And the answer there is a diagnostic suppressor, which is also a plugin that we can write with Roslyn. It's very, very similar to a diagnostic analyzer that we wrote last time. As a matter of fact, it even derives from the diagnostic analyzer. And then we will build tests and write some production code and see how we can programmatically only suppress this rule from test methods. And we will continue after a brief break. So, see you back in 5 minutes. And welcome back. Thank you for sticking around. So I made a little modification off screen, or off stream. I have changed the analysis mode from all to default. So not all of the rules are included, but then explicitly stated in a root of the repository, a global config file, that I want to set the severity of this very specific warning to, of this specific diagnostic to warning, so that we declutter a bit the warnings. So we previously had more than 300 warnings. We only have 138 warnings left, and this is all the CA1707 that we currently care about. So we will now try to get rid of only this. All the other warnings I will fix off stream and will be then part of the PR that I suggest for after this stream. So now let's build the Roslyn thing. Yes. Let me jump one more time to the document, to the discussion page. So I linked the documentation for the actual warning, the CA1707. So let's go find that warning. Actually, somebody must have built this. So this would be in the Roslyn analyzers repository. This repository contains most analyzers that we get with .NET. It also contains the meta Roslyn analyzers that I showed last time. So let's go to the not sure in which project actually, so let's try find it. Maybe something with underscore. Identifiers should not contain underscore. Yes, and there is the fixer as well, and tests and so on. So this is actually the code of the diagnostic that we now want to suppress for only test methods. If we see here, this is the rule, C1707. So all the rules with analyzers, they are a specific string. So this should be unique to explicitly specify or suppress this one rule. And we see that this has multiple diagnostic descriptors, since they are reported not only on methods, but also on an assembly level. So if an assembly contains underscores, if a namespace contains underscores, if a type contains underscores, and so on. So this is actually the one that we want to suppress, the member rule, since that's the method. It also applies for type parameters and method type parameters, and so on and so forth. So this excludes all of the underscores. And if we would scroll to this code somewhere, it checks if this identifier contains an underscore and then reports the warning. So we're gonna need this for testing. So for the testing part, we need this very analyzer to actually report the diagnostic. And then afterwards, we fire our suppressor again, which then gets rid of it. And we will build the suppressor via the Diagnostic Suppressor implementation. If you're not aware, but you can browse the .NET source code not only on GitHub, but also via the page source.net. So that's source.net. And for example, here we see all the implementations, for example, a task of T. And we could go to the, if we click web access down there, we actually then go to the GitHub page. Now, this also exists for Roslyn, for the Roslyn source code. And this is, I linked it here. This is the page roslynsource.io. It's very similar. And let's find our diagnostic suppressor here. And there it is. So this is the class that we will implement and can then put into the NuGet package, so we can ship this suppressor to everyone who wants to get rid of the CA707 for test methods. And indeed, this is derived from a diagnostic analyzer, so they're really very similar. They play, well, they don't really play together. The suppressor plays against the analyzer, but yeah, they belong together. So this is the type that we want to be building. Now let's jump to the solution and create some types. So in our production source code, I will actually create a new directory. I call it suppressors, and create now our suppressor. I call it the CA1707 Diagnostic Suppressor. I copied the name because I also want a test for that. I go to the test project. Also create the same hierarchy there, have a suppressors directory. So this will be our namespace for the CA1707 Diagnostic Suppressor tests. Since this is a test class, this needs to, well, let's figure this out along the way. Okay, now I tried this previously and I actually by my own couldn't get it running, to get the testing running. The packages that I'm using for testing is, oops, that's the wrong project, are these packages, which are the Microsoft Code Analysis testing packages. We had a brief look at this last time. I'll go to there again. If we just go search it, there is a this thing. It goes to the projects. I actually want to go to the page. Yes. So there is a bit of documentation on how to use these Microsoft.codeanalysis.testing packages. This is how we can test our, or how we tested last time, our diagnostic analyzers and code fixes. We will also use that to test our diagnostic suppressor. But this documentation is not 100% complete. I couldn't find out how to do it actually, and then found a GitHub issue which discussed that. So actually I asked for supporting this because I thought it wasn't supported, but it has been supported already. And it's in here. And I want to find now that there's also a nice example that we are going to be inspired of. Live example of usage can be found here. Yes. So this is what we were going to use to build our test. So let's start with the test. Actually, let me copy this. Go to our test. Edit. Now we immediately get an error from the XUnit analyzer. Test classes must be public. We can apply the fixer. And let's see. So let's actually declare. So this would be, oh, this needs to come up with a name here, but let's declare our test code. So we will be using XUnit. And we will have a public tests class, which now has a fact attribute on a method. So we will have our void test method. I call it now like this pattern. It is method under test scenario expected behavior. It can be empty. For now, we actually use tabs. And we also need to add the attribute. Since it doesn't exist in this compilation, we could technically, with this testing framework, load the, in this case, XUnit assembly into it, but perhaps it's a bit more simpler to just define this fact attribute. So I go to the definition and basically copy this. So we will be in the namespace XUnit. we will have a fact attribute which has, do we care about these members? Perhaps not, but let's add them for the sake of completion. Need to search what the accessors are actually. And this is actually not this. There is a pre-release of XUnit. Actually, let's check this out. XUnit source, where this fact attribute also has nullable annotations by now. Yes, but let's ignore the nullable annotations in our test because they make no difference here. We can also get this attribute usage. So we are going to need also to import the system namespace. And okay, all of those have getter and setter. So now we need to specify the warning actually, or the suppression, but let's do this afterwards. I'll keep this empty for now, just say bool, we will change that. And we need the method that we actually run. So I do have helpers for that, for the other types of Roslyn analyzers. So I will actually copy the helper set that I have for diagnostics and change this to suppressors. So we're gonna do some renaming. This will be the analyze diagnostic suppressor verifier. Oops, double P, suppressor verifier. And the diagnostic suppressor tester. Okay, I need to zoom out a little bit. And then we can get a helper method that we used last time as well. So let's actually catch that. And put it into our test here, where we can pass in our suppressor and verify. So we have a verify type which contains some shortcuts. We also need to add the diagnostic suppressor over there. So this is in the verify type. There we have some entry points for the diagnostic analyzers, for code fixes, also for refactorings. And now we are going to add a new one for the diagnostic suppressor. And we need to pass two types to this setup that we do here. First of all, the diagnostic suppressor. This would be our code, and as our code that will suppress the diagnostic. And we also need the original analyzer which produces the diagnostic. So we need to pass in both of them, where we do the type constraints that the T of diagnostic suppressor is indeed of diagnostic suppressor. Let's order it correctly. And we here then return the diagnostic suppressor verifier that we just created with those two type definitions. This will be diagnostic suppressor. We don't have that available in the project. Haha, diagnostic suppressors. Let's check the documentation. Since when have diagnostic suppressors been available? Since Roslyn 3.3.1. So this testing helper project that I have we need to actually update it to at least that version. So let's do that. Yeah, we are still at 1.3.0. That's very early version. So let's update to this. We won't be needing this anymore with that. There was a compatibility thing with this very low version. Okay, now it should be available. Yes, excellent. And the diagnostic suppressor verifier. We haven't defined the constraints quite right yet. So let's go to that type that we previously copied and now have a new. Let's add those generic type constraints here as well. Okay. This will be the diagnostic suppressor. Let's have a brief look. Doing everything correctly. This will be, we will create the diagnostic suppressor, of course. And add the diagnostic suppressor type. And we need to do this just one more time for this tester helper as well, where we pass in both the diagnostic suppressor and the diagnostic analyzer. But the thing that we want to verify is now not the diagnostic analyzer, but actually the diagnostic suppressor. So we copy the T of diagnostic suppressor. And this is the C# analyzer test. This is the type which is provided by Microsoft code analysis.testing, which enables then verifying our code. Okay, so this should build, if I haven't missed anything. I did miss something. Do I have a typo? Or not? Type constraints not right. You have the suppressor and the analyzer. Why does this not compile? Space could not be found. Oh, no. We're in the verify method. Okay. We need to fix the namespaces of those new types that we created, because I just copied them, but I didn't change the namespace. So here are our two new helper types. They're still in the diagnostics namespace. They need to be in the suppressor namespace. So there is also an factoring for that, where we can, come on, Control dot. Yes, we can change the namespace to match the folder structure. This is what I like to do. So now they are actually in a different type, and now we could go to the verify type and include that using, I actually do have a typo. Yes, I had a typo as well. And return that. Cool. Let's go to the test. The CA1707 tests. Here they are. And we can now call here diagnostic suppressor. We call it with our suppressor, and now we need to specify that analyzer that produces the warning. We had a look at this previously. Do I still have the tab open in the source code? No, I'm afraid I closed it. No, there it is. So we need this very type. Identifiers should not contain underscores analyzer in this namespace. How do we get that? This was revealed to me by this example. If we go to the CS proj of this example, we see that the author is including this net analyzers package manually. So if we use those are exactly those analyzers, this code analysis.net analyzers, the ones that are included since .NET 5 SDK already in the SDK. But for this, we need to include them manually so that we can actually access that type. We are lucky that this type is actually declared public, so we can just refer to it. So let's go to our analyzer project and to the test project and include that using. I like to shorten it, private assets all, and can get rid of the rest. Yes. Oops. Okay, now we included, actually let's go to version 6.0 since this is the latest. Okay, and we need to add also, since those are analyzers, what I showed last time in the NuGet package, they are not in the lib folder of the NuGet package, they are in the analyzers folder of the NuGet package, so they won't be available to user code. And with, oops, that's the wrong, here's the example. With this MS build item group, we can, I believe this is the path then in order to also reference this DLL, to actually reference the DLL, so we have access to those types. We shouldn't do this in any production code, but for this test setup, this is what we have to do. So we'll add this as well. And now I hope that this type is now available. What was the name again? Let's jump to the source. So it's Microsoft Code Analysis. I will copy the name here. Dot identifier should contain. I have the full qualified name and put it here. And there it is. Cool. We can now F12 it. And we see this is the CA1707 analyzer that we just had a look at the source code. So I don't have these. What did I do wrong? Why is it not compiling? Can't be used. Diagnostic Suppressor. Oh, okay. I believe I made a generic Diagnostic Analyzer is Diagnostic Analyzer. Should work. We first pass in the type of the suppressor. And the suppressor is constrained to Diagnostic Suppressor, and the analyzer is constrained to Diagnostic Analyzer. So I'm not sure. Why this doesn't compile. Oh, yes. Our type isn't deriving from Diagnostic Suppressor yet. So let's do that. Yes. Okay, now it's a Diagnostic Suppressor. Let's implement everything that we need to implement. We also have a warning. We need the Diagnostic Analyzer attribute. It's the same attribute that we also needed that for regular analyzer, so that the build tooling can and the IDE can pick it up. Okay, now it compiles. Excellent. So we can now call into this verify async that we built and should have. Let's run the test and see what we still have to improve. We need to do, I believe, 2 more steps to set up, and then we're good to go. So let's jump to the suppressor tests. Yes. So it fails because we have a mismatch. We expected 0 diagnostics, but actually had 1. Okay, yeah, okay. Our analyzer is throwing an exception. We need to fix that. So now we need to create just very similar with the Diagnostic Analyzer. We declare in this property, in the supported suppressions, the rules that we can exclude. So let's define that statically here. We make a private static read only. I used to call it rule. We need a type, of course, suppression descriptor. Created a new. What does this one need? It needs the string ID. This is a unique identifier for the suppression. So this is our identifier. Then we add the suppressed diagnostic ID. This is the one that we actually want to suppress. So this would be the CA1707 in our case. And then we can add a justification about why we would suppress this rule. So first we add our diagnostic. I use the very CA1707, but add a F0 in front of it. And we want to suppress the CA1707, and as justification, test method names should follow, should contain underscores to separate method under test scenario and expected behavior. And then we want to create an immutable array here. Immutable array dot create of this type. Actually, this can be inferred, so we put in the rule in there. So this suppressor only supports suppressing the rule CA1707. And let's get rid of this throw. So let's basically do nothing in here, add a to do, so that it doesn't throw. We can go back to the test and run it again. And it passes. So now we need to set up that this analyzer that we now passing into this chain actually produces the diagnostic. So we need to again have a look at the example, because this was solved there. Let's have a look at the test. So the test actually also declares here the diagnostic that we want to suppress. So let's do this right away. We are suppressing CA1707. Now this extension method, or this method, does not exist yet, because we also need to upgrade our Microsoft.codeanalysis.testing packages. I'm still here on an older version, so let's go ahead and do that. We can jump to, those are actually now not available at the NuGet feed. We only have version 1.1.0 available. So you need to go to the preview feed, where we have the latest beta versions available. And I will update those 3 of them. Actually, let's have a look at our NuGet file. So how is this feed defined? In the root of our repository, we have a nuget.config. And we see we have the regular nuget.org feed, but also this .NET Tools feed, which includes preview packages of the Microsoft Code Analysis testing packages. Now this should become available soon. Let's do a build. Unless the update failed. No, we are at the latest beta. Should be fine. Yes, now it's compiling. And okay, so we got that. What else? And this seems that the rest we have in place. Okay. Now we need to go to the verifier and see what they are doing here additionally. So this is very similar to our code already, but here we now have one additional step where we transform the solution, and we get the project, we get the C# compilation objects of those projects, and then add specific diagnostic options that we extract. Here it's called the system analyzer. This is the underscore analyzer that we are actually injecting. So we get the supported diagnostics of this analyzer and then enable reporting them for this test. So let's actually copy that, put this, follow our code, put this into the, do we put it in here or do we put it into the tester? Let's put it into the tester. So we create a, here we need to new this type of diagnostic analyzer. We assign that. We select, actually let me call this diagnostic. And this now is an ID. So we select the IDs of the diagnostics and then create a dictionary of type string and diagnostic, report diagnostic. So actually we want to have this as a warning. So we basically simulate that this, or we enable that the CA1707 can be reported as a warning. And now we need to add this to the compilation options. I will copy this solution transform. I think this is part of the tester, isn't it? Yes. So we have a solution. Actually, let me strongly type this. This is a or explicitly solution. Then we have the project ID. And I don't want to do this. This would be the code that if we don't want to specify the attribute in our test code, this is how we could load this attribute into this ad hoc compilation. But since I want to have it in source to be a little bit more explicit, we don't need that. We get the project, get the C# compilation options, and then let's perhaps ignore those two for now. Perhaps you're not going to need them, but set this with specific diagnostic options, where we indeed pass in this dictionary of string and report diagnostic, which is the ID and the severity. And let's run the test again. There it is. No, where it is? There it is. Let's get rid of this additional usings. Yes, and let's hope this test is now failing as expected. Okay, I hope it's failing as we do expect. We get an item with the same key has already been added. This dictionary insert, try insert. So we are failing. Okay, yeah. So the supported diagnostics of the, let's jump to the source of the, no, where it is? There it is. Of this diagnostic. So where are the supported diagnostics? There is somewhere a property supported diagnostics. There it is. And it contains many rules, more than one. But all of those rules have this ID CA1707. They're just different descriptors which carry different messages, but it's still the same rule ID. And we would map them now. Now we have the key multiple times. So we could either select or group them so we only have one, or I guess it's simpler to just do it to an immutable dictionary. Immutable dictionary, because that I think gets rid of duplicates. Or does it override them? The actual logic I'm not sure, but at least there are no duplicates, and this then only have the key once inside. And it seems it does. The test is passing, but the diagnostic is still not reported. Is there one last thing that I miss? We have it public. Let's check out the example again. There must be one step. Okay, I forgot to actually supply the system analyzer. It's instantiated, so there's the compilation or the driver which creates the analyzers and then invokes them to report the diagnostics. It only includes our suppressor, but not the analyzer yet. So we need to add that as well to our tester, I believe. This is overridable here. And we need the systems analyzer. Okay, so let's do a property there. Let's make it internal. It's the type of our analyzer that we want. Analyzer. Let's instantiate it here and return that. So we call into the base, get the diagnostic analyzers. This should yield, I believe, but let's have a look at this. This should just yield the suppressor, and then we add the analyzer to that. And actually, let's use the same instance. So not new it here again, but refer to the very same instance of the tester.analyzer. Okay, I will now debug the test and see if we actually jump into this new method that we overloaded. Yes, we are. And not sure if I'm correct. So has this already been invoked? So it now includes the diagnostic suppressor and the our diagnostic suppressor and the analyzer from the net analyzers package. So will this now cause the test to fail? Yes, because mismatch between reported diagnostics. Yes, we expected 0 diagnostics, but actually had 1 diagnostic. Cool. So now we actually get this. Oops, sorry. Let me zoom in. We actually get this diagnostic. So we have a warning CA1707. Remove underscores from the member name, our test method. So now we can complete the test. We now expect that this diagnostic, the CA1707, is at a specific location. We can say with location. I use the markup index 0, and I want this to have with suppression. With is suppressed true. So the analyzer should then result into suppressing this. And now we need to, the 0, we need to specify up there with the syntax that I always need to look up. I believe it's also mentioned in the example. Yes. So it's opening brace, pipe, number, then the ID that we have indeed 0, and then we end it with a pipe and closing brace. And let's see that the warning is indeed just reported on the identifier. Let's go back to actually any unit test. I add here underscore to do. This should now start with a warning. Yes. So it's reported on the identifier part of this method declaration. Okay, so we simulate the same here. Excellent. I believe this is our failing test that now should invoke our okay, we still have a warning. Expected diagnostic ID to be, but was the same. I guess the message is not the most helpful, but we see that. I think it's now this is suppressed property that we have. We expect it to be suppressed, but it wasn't suppressed. So if we would now put a breakpoint into our analyzer, into our suppressor, we should jump into this method. And we are, yes, okay. So much for the setup. Now it's analyzer time. So, okay, I am checking. Okay, so let's check out the suppression analysis context that we have. We have a collection of reported diagnostics. I assume we need to for each that. We get the compilation, so we can get information about whether this error was reported, or this warning was reported on a method. And we don't need the analyzer options for now, but we have a cancellation token that we should pass down into methods which can take it. And we have two methods. We can get the semantic model. Last time we didn't really needed it, but we may need it today in order to find out if this attribute is really the attribute that we desire and not just any attribute which is called fact, but in a totally different namespace. And the actual method where we report the suppression, which then would suppress the diagnostic. Okay, so we believe first we need a for each to go over all the reported diagnostics. This is of type diagnostic. Okay. And now we need to see, because what we see in this example, the diagnostic here also has a location. So we can get basically the location of this diagnostic and then get the type of it, because we want get the node of it where it is contained, and it is contained in the method declaration. So we need to find out. Actually, let me add a to do. We also need to test that, for example, a property or a class, test that not suppressed on a type. So we really only do it for a method. Or, yeah. Okay. So from the diagnostic, what information does the diagnostic carry? It carries the location. We're gonna need that. It carries the ID. Well, we know the ID already, so we're not gonna need that. Perhaps we need the descriptor. Yeah, but we definitely need the location, and with the location, we can ask the syntax tree. The location is within a syntax tree. So we can say diagnostic.location.syntax tree. No, we can't. Source tree. Okay. So this is our tree. Let's actually have a look at this. This should be the source code that we require. Test Explorer. Let's run the test. So this tree should carry, if I would toString it. Yes, so this is our test code. It has the to do as well. So excellent. So we have the tree and the location of this. So we should be able to get this node now. Okay, so we can ask the tree. No, do we need the... We can ask the tree. let's have, I'm not entirely sure. Let's open the example. So this is now the from the example. I'm also building a diagnostic suppressor. So let's get a little bit inspired there. They get the location, the source tree, gets the root of the tree, and with the root, then from the root we can find a specific node at this location. Okay, this is how we get the location, or the node of the location that our diagnostic is reported via the source span of the location. That's cool. Let's grab that. So we need to get the root. And this root, I believe, takes a cancellation token. So always pass that cancellation token down to methods which support it. This would be our root. This is a node, I believe. Yes. So we have our root. And we can diagnostic.location.source span. So the location has a source span, and the source span is, okay, the start and the end. So this is really the location in our source text. And we ask that to get the node from here. So this is now our, this is the node. Now we need to ask, is that node, let's not do that, let's do that afterwards. Let's be naive, let's assume that this is now indeed the method that we want. So let's cast that into a method declaration syntax. How I know that this is a method declaration syntax, I can show this again. So with Visual Studio, if you have the .NET extensions, the Visual Studio extensions is it the Roslyn SDK? I need to look it up. From the installer, if we have the .NET Compiler Platform SDK installed, then we get something very similar that I showed previously in SharpLab. We can get the syntax visualizer, and here we can see how this tree looks like. Let's pin that for now. Yes, and a little bit bigger. Let's zoom in, and here I highlighted this method, and we see this is the method declaration. And this method declaration has an attribute list. I believe if I would remove this here, then the attribute list has gone away. So we will get the method declaration and check the attribute list for any attribute that satisfies our condition that it is some test relevant attribute. Okay, let's hide that again. So this is now our method. And let's get the attribute list. Attribute list is a syntax list of attribute list syntax. So this is a list of lists, I believe, because we could write something like, if I put a, let's do an obsolete attribute, we could either add multiple attributes like this. Well, this doesn't work because obsolete attribute is only allowed once, but so we could attributes like this, or we could also comma separatedly add them. And this is why it's a list of lists, because here we have 4 lists and the first list has 2 items. So this is why it's a list of lists. So we can do, I believe, select many. I will use this so rarely. If Timo is still watching, I think you would know. Select many, so this would be our attribute. And attribute, we can check the, what do we need from that attribute? Or should we, let's just extract the attributes. Ah, this is an attribute list. Okay, okay. Of course, this doesn't know how to select it yet. So from the attribute list, we need to select each attribute. And the attributes in turn is a list of attributes syntaxes. Okay, do we need to say attributes.attributes? No. Because this is a separated syntax list of attributes syntax. And here we have the nodes. Okay. I'll briefly jump to the example. So we get the attribute lists, we select many from the list, we select the attributes. And here we do first to a default, but let's actually get all of them. Okay, so var attributes. And from there we can we again select many? No, this is already the attribute from which we could get attributes. We get the attributes. So we now have a flattened list of attributes. I really need to practice my link. This is an enumerable of attributes syntaxes. Ah, okay, so that's actually what we want. So yeah, now okay. Attribute. And from this attribute, we could check the, should we check the name? We should actually get the type of it. I have a déjà vu. I already did something very similar. Let me look that up. I think it was in the null and void talk. Built an analyzer there, which also reads attributes. We have to try get attribute. Oh, but this is a symbol now already. Can we get to the symbol? Actually, I would like to have the symbol, yeah. Not the syntax. Because with the syntax tree, we only know the name of it. But we don't, so this could be any name. We don't really have a semantical association to this text. So let's try to get the symbol. How do we get the symbol? Via the semantic model. So we get the semantic model and can get type information about that. Okay, so we have the context. On the context we have the get semantic model. The get semantic model takes in a syntax tree. I think we pass in our root there. We have our model. Not sure if this takes a, also no, a syntax tree, not the node. The node is a, so we need to pass in the syntax tree, of course. And then can ask the model to get us the type information about this attribute. This, let's see, the overload, does it have? It also carries, it also allows cancellation. So we pass context.cancellation token in there. cancellation token in there as well. Now we have the type info. So this type info now carries information such as the nullability information, but also the actual type, and we want that type symbol. So we can ask if that type symbol, let's check the name of it. If the name equals the attribute that we want, which is, the full name is, let's put that, should we put that? Yeah, let's put it into a private, private const string x unit fact, which is x unit dot, fact attribute, and we check if that equals that string comparison dot ordinal. We learned it before. Something maybe now, I will check for this later. And if any of our attributes on this member, on this method, is the XUnit fact attribute, then we can break out of the loop, but also report the suppression via context dot report suppression. What does report suppression receive? If it receives a suppression, we can create a suppression via suppression.create, where we pass in a suppression descriptor. We already have that. And the diagnostic. I believe we have both. Suppression.create. We can say var here. We do have the suppression descriptor already. We can reuse that. And the diagnostic that we want to suppress, which is the one from up here. And we suppress it. And this may be it. Let's find out. Let's run the test. And it fails. Expected there was to be, but was. Okay, so it does not suppress it. Let's debug into it. Let's see where I made a mistake. So we have the tree, we get the root, we have the node. The node is indeed our method declaration syntax, which carries the fact attribute and the name, with the entire method declaration. We jump into our, let's see the attributes that we have. We have only one attribute, the fact attribute. Cool. We get the semantic model, get the type information. So what's the name here? It's fact. Ooh, it's without the namespace. Actually, I want to have it with the namespace. Is the toString giving with the namespace? The toString is with the namespace. Okay, then we should toString it, because I want to be as precise as possible. So it could be any fact attribute if it's not. I would assume that if it's the fact attribute from the XUnit namespace, then it's somewhat safe to say that it's exactly that fact. It's still maybe a different one because somebody declared it, but that's maybe a corner case. I guess this would be good for a start, or good enough for a start. So we toString the type and then check that. Let's run the test. I'll debug the test again. We jump into the for each, and now the equal matches. We create the suppression, break out of the loop. Cool. So the test should turn green, but it doesn't. We remove the underscore. It still doesn't seem to. Now, is my test setup wrong, or is it actually not suppressed? I will find that out by running this as the Visual Studio extension, basically integrated into an experimental version of Visual Studio, and let's see if it is working there. Actually, let's add a test project to our examples here. Add new project. XUnit test project. We add it to the examples directory and call it example.tests. Oh, no, 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 no. In the root, let's put it here. Yes. .NET 6, yes. Method scenario underscore expected. Now let's run that in experimental version of Visual Studio. Open that solution filter. So it's a filtered solution that we created. It only contains the example projects, which I now realize I still need to add it to this filtered solution. So we can say show unloaded projects and load that new project as well. Reload project and update the solution filter so it's now part of this solution filter. Cool. Okay, let's jump to the example, and here it is. Actually, we have no warning. No squiggles, no warning in the solution. What if I remove the fact attribute? We get a warning down there. It's CA1707 and we get it up here. So the suppression seems to work, but my test setup is missing something. I will once more go to the example implementation. Let's jump to the tests. Let's see what I am missing that we have as well. We don't have this. Well, let's add it. Let's jump to our tester. Okay, we can set the test behaviors here. No, we can't. Yes, we can. Semicolon, yes. No, just colon. Comma, that's a comma. We have that. We have the solution transform. What am I missing? Perhaps let's jump back to the original issue. Maybe that contains more information. Perhaps there is something that we are missing. We don't have that. No, perhaps we need that as well. That's in the diagnostic verifier. Is that here? No, it's not. That's in the test type. So it must be this one. And where should we add this in the constructor? Let's add that in the constructor here. Okay. Citor, where we have, what do we have here? We have a diagnostic result and a verifier. Diagnostic result and a verifier. We check if the result should be suppressed and then equal. So this may be the solution. It seems promising. So it tells the verifier. The verifier is actually the XUnit part of it in this chain. So we have an XUnit verifier here. If we would use another testing framework, then we would have an MS test verifier or an NUnit verifier here. And it would tell them to check if the should be suppressed is actually matching the suppressed that we pass in as an expected output with a message if it isn't. But is this now replacing the check or adding on top? Let's find out by running the test. No, that wasn't enough. Still get this error. Oh no, I have a typo. Okay, I have a typo. It's not 7001, it's 7007. Yeah, so that's my bad. It must be 7007. This is the diagnostic that we want to suppress. Let's check again. Yes, CA1707. My bad. Okay. Oops. Oh, so I renamed it, but not down there. Now let's run the test again. Green, 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 green. No, still not green. Expected diagnostic rated to be error, but was warning. Ah, okay. Oops. Uh-oh. What did I do? Sorry. I expect a compiler error, but it's a warning. So I say compiler warning. Yes. Are we almost there? Green. Yes. There we go. It passes. Excellent. Cool. Now let's give this name a proper test. No. Yeah, strike that, reverse it. Give the test a proper name. So our method under test would be report suppressions. Our scenario is n-unit test methods. Test method. And the expected outcome is suppress CA1707. Now let's do the to-do here. We want to have a test. I will copy this. Want to have a test which n-unit, I call it a regular method, and do not suppress CA1707. So now let's remove the fact attribute from there. Now it's a regular method. I'll leave the rest the same, and this should not report the diagnostic. So this should, now we could say, I think with is suppressed false, but we already set it up there. Is suppressed false. So we should be able to get rid of this one and have another passing test. Yes, green. And we need one more test where we check if something is not a method. Because this diagnostic also reports, on, for example, property. If I have a property and I call it my underscore property, this would again report CA1707. So this is our example. I call it if it's a non-method node, do not suppress. So I put in this property. Perhaps also let's do it on the test as well. So, or on the type. So we now expect two diagnostics, once on the type, once on this property. I give here location 1. Close the span and expect to have two diagnostic CA which are both, with which neither is suppressed. So let's test that and actually expect this test now to fail because we hard cast into a method declaration. Oh, okay. But I believe the analyzer crashes here. It passes, but because this should dramatically fail actually. If if we debug into that. Because this is now this node is now a class declaration. Can't cast a class declaration to a method declaration, so this will fail. Okay, unable to cast. So it seems that this here doesn't, if the suppressor crashes, if the suppressor crashes, then the diagnostic is not suppressed. And it seems this is not recorded. Not sure how we could create a test for that, but yeah, how we can create a test for that. We could if we also put in something that may be suppressed. So let's also put in a test method with defect attribute. And this is now location 2, and with location 2 we expect it to be with is suppressed true. But I now hope that does the entire suppressor crash, or will it then be is there a new instance per node? I'm not sure. Okay, but the test fails because expected diagnostic suppression state, it doesn't match. Yeah, so it's not suppressed. Okay, cool. We have a failing test. So we can now fix that. We can say if that node is a method declaration syntax. Actually, if it is not a method declaration syntax, then we continue the loop over all the diagnostics that we got. And otherwise we declare the method here. Okay, cool. This should now it only works on method declarations which have the XUnit attribute applied to it. I hope this test passes now. And it does. Excellent. So what would be the next steps now? The next steps would be to also support, let's go to the documentation. No, not to that documentation. Let's go to the unit testing best practices. Yeah, so our XUnit example, we accounted for a fact, but we haven't accounted for a member for a theory yet. So we would need to add the same thing for a theory. Let's do that, and then what I will do then, what I most likely will do, what I definitely will do then off stream is to also add the NUnit equivalence, which is the not the test fixture, but the test attribute and the test case attribute, as well as the MS test equivalent, the test method attribute, and the data row attribute. Unless, okay, I need to find out if the data row attribute actually requires a test method. So I need to find out what the rules actually are when a test method for each of those 3 frameworks actually is a test method, and then include those attribute names in the logic. So I will now do it for the theory as well, and the rest of stream. So let's build one more test. Actually, we have some duplication. We always add this attribute. So let's get rid of that. 1, 2, 3, and let's define it here. We have a private static, no, it's a const actually, string NUnit fact, or let's call it the NUnit attributes. Let's add all of them. Oops, this is also a verbatim string, yes. And we can actually, we can edit down there, then we only need to edit at one place. We say here the original code plus our NUnit attributes. Okay, now we have a little bit, zoom out a little bit, we have a little bit simpler, shorter tests. Cool. And let's build let's use this one. A test where we have the NUnit test method, it's NUnit theory, which should suppress. So we do a theory. So we also need the theory attribute, of course. How does this one look like? It is also in the namespace XUnit, and it's basically derives from the fact attribute. I will add it to our attribute declarations here. So we have this class. We also put on the attribute usage, and it's super empty. Cool. And we also need the inline data member. Inline data. Let's actually use this example. Put that here on top as well. And okay, int number. And how does the theory inline data look like? Copy this attribute as well. It's also in the XUnit namespace. We have now a sealed attribute, which actually has, I guess I wouldn't need any of the members, but let's add them for, yeah, we won't need them. Actually, because we only care about the attribute itself, not the members which are set on the attribute. Do we need to care about an ignore? No, if the test is ignored, the rule still should be suppressed. Okay, so yes, now we have theory. Well, the test is a fact, but we test the theory, which should also be suppressed. So location 0 should be suppressed true. And let's now run all of our test suite. Let's run all our 4 suppression tests. Ooh, mismatch between, we expected 1, but actually 6. Inline is not an attribute class. So, I made an error in the attribute, in the inline data attribute. I don't have the data attribute declared. Well, I could actually get rid of it technically, because we could just derive from attribute, but perhaps for the sake of completion, let's get the data attribute in as well. And this is now just deriving from attributes. So we put in that as well. Namespace. This is now a different namespace actually. So namespace xunit.sdk. The data attribute, which has a virtual skip. Get set. I think I'm also namespace. Do I do this? No, this is one. So needs to outdent. Okay, but the inline data is That's not in the SDK namespace, is it? No, that's just in the XUnit namespace. Okay. So let's say .SDK data attribute. Okay. Now this does not turn green. Okay, I'm now doing some this requires constructor. I will, for the sake of simplicity for now, I will get rid of the derived things here. So I call this is just an attribute. For the sake of simplicity, I will then complete the example of stream. But we have one error. Ah, yes, of course. This does not get suppressed. The inline data. We need a constructor for the inline data. I guess this is some params constructor, isn't it? Yeah. So the theory gets this constructor. No, not the theory, the inline data. Here we go. So now our test code should compile. But we should still have a mismatch, yes, because this does not get suppressed. Now we need to also watch out for the theory attribute. So it's a theory attribute. It's also in the XUnit namespace. So we can either add it here, or we just say we make a string collection of test method attributes. New, I think we should be able to declare it like this. Are we? No, we are not. I need to say new. So can a string be const? A string array can't be const, can it? Yes. Read only static. Oh, I can. Yes. And we have the fact attribute and the theory attribute. One more time, let's run all the tests, and if build error. So yes, I of course need to implement it like in contains. Can we do a contains if this one contains that string? Running all the tests and see them all be green. Woohoo! Let's do some cleanup. We still have some warnings here. The location may be null. This may not have a location. I'm now wondering, could it be that this diagnostic does not have a location? Perhaps if it's on an assembly level, this could crash our analyzer. So to be sure, let's do a if location is null. If we have no location on that diagnostic, then continue. Oh, hold on. No, it's not the location that is null. We always have a location. I'm sorry. It's the source tree. We may not have a syntax tree on that. Or null if it is not in a syntax tree. May the assembly, because the CA1707 may also be recorded on assembly level. Not sure if this actually would have a source tree. Just for safety, I will do a null check here, so that our analyzer or suppressor doesn't crash. Okay, so where else do we have a warning? We have here one more warning that type may be null. It's also annotated nullable. So type of the expression represented by the syntax node. For expressions that do not have a type, null is returned. Since we are on attributes, I would kind of assume that we always have a type on there. So I would go with a debug assert here. I expect this to be not null. If it was, then we could say expression this attribute does not contain a type. Okay, now we have, those are some infos. We have no warnings left other than the entire solution that we could now fix by deploying that analyzer, that suppressor, and including it into that solution. So my to-do here is to also include the MS test attributes and the end unit attributes. Cool. And this is the very first diagnostic suppressor that I have now built fully. I want to see it in action one more time by deploying it as an extension to experimental instance of Visual Studio. Go to our unit test. I will then also expand these examples to also do the, actually let's do the theory right there. Theory. So we have effect, we have a theory, and let's have a private static void my underscore method. It should still report on there. We don't want to suppress it here. Must have test data. So we need to add inline data true bool value, and should we use it assert dot do I have fluent assertion there? I rarely use these actually. Assert dot equals, no, assert dot equal, and then we pass in the not if we pass in the expected first and then the actual. So there is a true, isn't it? Expected true, yes, it's better. Value. Okay. So why don't we have a warning on this method now? Do we made a mistake in the analyzer? In the suppressor. What does perhaps this diagnostic only doesn't fire on private methods, perhaps, if I make it public? Now it is. Okay, so this suppressor is configured to only include public. Does it also include internal methods? It does not. So it only fires on public methods and types, I suppose. Okay, so this is expected to have. Cool. Okay, this is now XUnit warning. But let's suppress the XUnit warning here actually, because we don't care about that one and justification. We want to see CA1707 not being suppressed here because this is not a test method. Cool. And my to-do here is as well add n unit examples and add the MS test examples. Excellent. Diagnostic Suppressor. Oh, they are cool. Once this package is published, I need to deploy this to all of my projects, so I can then don't need to, for all the test projects, explicitly ignore this rule, because I tend to use this underscore syntax for all of my test methods. Cool. Now I require a bit of a break. I'll be back in 5 minutes. And welcome back. Thanks for sticking around. So we built my first diagnostic suppressor. Now I'm wondering what's next. So we have, last time I was a bit overtime. I always want to keep going roughly around 4 p.m. UTC. So we have 30 more minutes. I would like to think about, not actually implement it, but think about another diagnostic suppressor that could come in handy. And also at the end, have a look at our reports. So our test coverage report and our mutation testing report. I will start them in the background so that they are completed at the end. And test dash coverage. Okay, I started both. Actually, can show them. So we have our mutation tests running and our code coverage. Oh, we have because we have warnings as errors. Of course, this fails. So for now, let me exclude this one again. Now they should keep going. Test one aborted. Something is wrong. Okay, I need to figure out what's wrong. Perhaps we have a look at these later. Yeah, I still want to go through the other analyzer, the other suppressor that I was thinking about. So I will actually now return to analysis mode all to enable all of the analyzers. And we also have a benchmark project in the solution. And if I would go ahead, so this is like via benchmark.net, we do the benchmarks via benchmark.net, and it's basically a console application that you run via, for example, the benchmark switcher, then give in the name of the assembly where your benchmarks are contained, and then can run it with various set of configurations. What if I would like to change this to C#9 style top-level statements? I could move the body of this main method, remove the class and the namespace, and just paste it here. But we would now get a warning because the top-level statement feature synthesizes a program file, synthesizes a program type, which then contains a synthesized main method. But if we also use this synthesized type name, then it looks just a little bit different. And now it's no longer, some analyzer now actually is triggered, which says that it's CA1812. The program is an internal class that is apparently never instantiated. So this is the synthesized class, the synthesized program class, which is created by the C#9 top-level statement language feature if we also use the program type. But this is an internal type which is not static and it's never instantiated. So this is now how the diagnostic analyzer now also is triggered there. Perhaps the diagnostic analyzer should already exclude that, but we could also have an a suppressor which now checks for that. But to set up in order to set this up, we would need to declare that this is indeed an exe. So this main method is only created for an exe file. Or is it? Actually, let's have a look at sharplab. How this actually looks like. Sharplab.io. If we have a top level statement, if we say console.write line, let's go. Okay. Maybe it does this actually create an X? Not sure. So this here we see it synthesizes a program and a main, but they contain unspeakable characters. So this is not valid C# actually. So this we can't use those unless we actually refer to that type. Let's do program here. And does not exist. Perhaps this is a C#10 feature. Could it be that we can refer to the program since C#10 and here we are not on C#10 yet? Yeah, okay, it seems so. It seems that this is a C#10 feature that we can access the synthesized program, and now we see it became now a speakable type. So the main is still unspeakable, but the program now is, and it's not static. And also there is no auto-generated comment, like something like this at the top of the file, auto-generated, which would prevent analyzers from actually analyzing this tree. But since this is not emitted, the analyzer actually is triggered there. So we could now, what I also want to now do is actually write a suppressor which suppresses exactly that warning. But I guess I will also do this off stream because otherwise I would exceed the time frame just again. So Timo, if you're still watching, this is what the next PR will look like. Okay, so let's check the agenda. We had a look at how those .NET 5 analyzers are enabled and are included in the .NET 5 SDK. We saw how we can suppress this via the preprocessor directive, via the suppress message attribute, also via the no warn MS build property. And we had a look how we could configure the severity of certain rules. In the example we did, we specifically stated a specific rule, like here. This could also, we could also add a category here. So if we know the category name, category name, we can control the severity of an entire category of diagnostics in one go. And we also had a look how to do this not only in the editor config, but also in the analyzer config, which is the .global config file. We had a look at this CA1708, which demands that identifiers do not include underscores. The CA1812, this is what we had a look at last, that internal types should be static if they are never actually instantiated. Of course, this rule doesn't trigger on public types because we don't know if some other assembly is actually instantiating them. We checked out what is a diagnostic suppressor, and we built the suppressor for CA1707. I marked it as optional. the other one, the top level statement suppressor for the synthesized program type, I will do later on. So if you're interested in that, I will eventually next week then have the source ready for that. And we still want to have a look at the code coverage report and the mutation testing report. I hope I get these running. I'm not entirely sure where the builds are failing. I am on the side here actually reverting some changes that we don't really need. We don't need that now. Can get rid of, can we? No, let's keep it. Those are the new tests. Yes, this we require that. Yes. Okay. Perhaps I had something bad in there. So this is the code coverage report. It runs all the tests and then checks the reported, the code coverage of all the tests. So this was not successful. Maybe because I ran them in parallel. Maybe this is why they failed. No, this one still fails because the task factory is not supported on .NET Core version MS Build. Ooh, because I have this analyzer project in there. Okay. Now let's for now exclude that. I will come up with a fix off stream. So the Visix project seems to be not supported. Maybe I just need to update to latest Striker, and that may already solve the problem. That looks good. That looks better. I still haven't updated. I will do it until the next session. Okay, that looks good. So let's have a look at the generated code coverage report. Let's zoom in. So, oops, that was a bit too much. Yes. Where is our suppressor? There it is. And that looks pretty good. Unless, okay, we don't have a test which fails for that. Maybe I will try out some things. If we could actually, let's do that right away. Let's do it after the mutation testing has finished. Yes, mutation testing has finished. The final mutation score is 4. Something is wrong with the setup here, I'm afraid. But okay, since this is complete, let's try if we can actually break the analyzer. Because what we saw in the source, what I'm not sure about, if we have a, since this is the diagnostic, the CA1707, it also has an assembly rule. And if that assembly rule now actually has a location, let's see. Where do we report that? Create diagnostic. I don't think that this has a location, and then I don't think it has a syntax. It may have a location, but maybe it doesn't have a syntax tree. Let's find out actually. So if we go ahead and we name one of those examples, or let's create a new one. Let's add a new project, class library. I call it class_library_1. add it to the example folder. Next. So now the assembly name contains underscores. Now let's include the source Visual Studio extension again. Set it as startup project, build and run, and see if the analyzer would be, or I would say analyzer, the suppressor would be failing here. Perhaps we can get inside as well via the debugger. Let's launch that. Also included to that solution filter, we will show unloaded projects. Reload that project. And unfortunately the breakpoint is not hit. But it should report it. So yes, I disabled the analyzers. I previously reverted a bit too much. Let's go back to let's just enable it on this project. Enable net analyzers, true, and we want to, the analysis mode should be all of them. So we do get the warnings here, but we have no... Okay, I don't see a warning on the assembly level actually. Maybe I misunderstand that rule. From here. Assembly rule. This is reported here, which is the compilation action. Compilation contains underscore. If the assembly name contains an underscore, it should actually. From namespace typing, but we don't get a diagnostic here. Not entirely sure what I'm doing wrong. Do we need to explicitly set it? The assembly name, my underscore assembly underscore name. Ooh, now we have it. Remove the underscores from assembly name. Oops, there it is. Oh, now it's gone again. It was there just briefly. Okay, I will investigate that. Maybe we could get rid of this safety check here, but okay, I will investigate this and follow up then in the discussion and then next stream as well. And the last thing for today is having a look at the mutation test report. There it is. Okay, we can go to our code analysis, and we have our, maybe this is why the code coverage is so low, because I experienced it last time with to only analyze the diff. So what has changed from the main branch, and so it would only analyze, or it would only mutation test all of our production code changes. So this is why we have such a low score, because a lot of things are not covered. This would explain it, but we have 100% on our diagnostic suppressor. That's pretty cool. Let's have a look. We killed 5. So those strings are all asserted. It's interesting because we don't really have an assertion for either our diagnostic ID or the justification. We only have basically the suppressed diagnostic ID. Okay, those we have, and it seems that down there not a lot of mutations have been created. This all resulted in compile errors. So a compile error is basically also a mutant was tried to be created, but then the compilation failed. I guess if we remove this, this continue here, then the flow analysis could would understand that this method here may be null because we don't break out, and it is not a method declaration, it's something else. So this method variable is null, and then we have warnings as errors. This would cause a compiler error. And so on. If we just remove, Striker also just removes the entire body and does nothing, this would also, I don't see how this results in a compiler error. Maybe because then this attribute variable is not used with warnings as errors, so it fails. But cool, 100%. So we killed 5 mutants. That's awesome. Okay, and I'm almost on time. This time I will finish on time. So I will next time review the diagnostic that I try to build for the top level statement ignore, and will follow up on this assembly level rule that I'm not entirely sure yet. We checked out the code coverage, we checked out the mutation report, and let's have a look at the next streams. So we're going to have, actually, so I want to do this session, the Let's Code session, I want to do every other week. And the next one is then the Saturday after the next Saturday, which is the 19th, again at 1 p.m. UTC. The topic, I'm not entirely sure yet, but it will most likely be source generators. Not sure which source generator we build yet, and if we're gonna build a source generator with the 3.8 Roslyn, so the original source generator, or we will build the newer variant, the incremental source generator. Not sure yet. I'm searching for a nice use case. And next Sunday, on the 13th, there will be a special episode where I invite 2 of my first .NET peers that I came along, from whom I learned a lot, and we talk a bit about .NET. We still have to define the time. I will announce that here and on Twitter at the end of the weekend. And with that, I want to thank you very, very much for staying a while and listening. I will also put the recording, so they are 14 days available on Twitch, and then at the end I will publish them on YouTube. So I will create a YouTube channel there if you would like to revisit a session. And yeah, I will announce that and post a link for the YouTube channel next time. So with that, thank you very much. And I will go to the exit screen. If I find it. So, .NET1, exit. No, what was the command again? Stop. There it is. Have a great day. Goodbye.